do that question, I want to show you something that I promised from the beginning. Okay, so watch, guys, watch. All right, so, I mean, this is what I promised from the beginning. I have it in the canvas shell. I think, that's obviously not a completely anatomically correct butterfly, but that is a freaking butterfly, yes? And there's one equation that created that. And here it is. Don't worry about R2, I'll show you in a minute. R1. It's my modified version, so it's like e to the sine theta minus 2 cosine 4 theta plus sine of 2 theta minus pi divided by 24 to the 5th power. Holy shit. Right, so I modified a few things. And again, I'm not going to test you on this. You're not going to get a butterfly quiz, right? I just want to show you. This other little dude down here just makes it even trippier. I just made it 8/10 of this, so watch what that does. It just adds a little more color to it. Weehaw. Okay. Weehaw. Okay. It just keeps going. All right. Anyway, so I just wanted to show you let me show you this too. So that's one thing. The butterfly curve, I promised that to you on Canvas from the beginning. Let me show you Desmos. Some stuff Desmos can do. So there's the butterfly curve in Desmos. It's just not as good though, so I don't care about that. Oh yeah, wait. Whew, okay. So R equals 3 sine theta. That is a circle on the y-axis. Why does that make sense? Because sine likes y. If I would have made a cosine, it would have just been sitting on the x-axis. Notice I've got a variable, a, in front of the theta. Can anyone tell me, we've done this before, what does that a do? What does that control? If I change that, what changes about sine? Period. Yes. Remember that? It's like K. I just use the letter A. Okay, so watch what happens if you already saw a little bit of what happens. If I change A by just a bit. All right, I changed A by 0.1. And this sucker blew the hell up, right? Whee! Tripedelic. Watch what happens every time. See how that's 3.2? Watch what happens when I get a nice whole number. Look at that. What's happening is, if I get a nice whole number, it kind of ends up retracing itself. If I use 3.1, every time it comes back around, it's a little bit off from where it was to begin with. So instead of retracing itself, it does the same shape just a little bit over. So that's why when I go off from a whole number, let's go to 2.9. Look at that. So it's just out of phase. It's not retracing itself. But if I go to like 4, there. How many leaves does that have? 8. And 3 had how many leaves? 3. So it seems like the odd K's, the odd multipliers, make that many leaves, but the even multipliers make twice that many leaves. Very curious. Okay, how hard is this to do? Just type R equals 3 sine A theta, and it actually opens up the slider. See that second thing, the slider I have for A? Okay. And then we got this weird stuff down here. Let me reset these before I do this. So look at this equation real quick. I have B sine C theta plus D cosine F theta. I can control B and D. I can control C and F. So if I just leave them all at 1, I get a circle. Why does it make sense that it's not on the y or the x-axis? Because it's made up of both sine and cosine. So of course it's going to be at a diagonal. So if I just change I just change B, for example, it grows in the y direction. Why does that make sense? Because B is the coefficient of sine. Yeah. If I change the coefficient of cosine, which is D, it grows in the x direction. Crazy sauce. So let's make it blow up a little bit. Let's make it 3 and 3. So now what's going to happen when I change the C and the F? Well, we kind of already know it should kind of trip way out. Bam! I mean, oh, that's some weird shit. You gotta love that. And it's relative, and every time I hit a nice whole number, it becomes very, look at this poor little dude. Sorry, you guys kind of see what I'm saying? So if it's a whole number, it ends up retracing itself. If it's like 3.1, 3.2, every time it comes back around, it's a little off. It's a little off, and that's why you get all these crazy spirograph kind of things happening. It's out of phase. There, yeah.
Is that like how ellipse behaves?
Say again?
Is that kind of like how ellipse behaves?
Let me see how to answer. Not really. You could argue that it's sort of related to it because I can make polar equations that give me an ellipse and I can control how like diagonal it is. Like in rectangular, I can only really handle these. But in polar, I can kind of make it rotate and stuff. It's not quite related to that. Anyway, okay. And of course, if I change the other, if I change the C piece, then it just makes it go crazy the other way. So if I change them both, okay, here we go. It just goes nice and crazy. It's awesome. Woo! Oh, cool. Anyway, all right. So, I mean, that looks, you got to even, minus the map, that just looks kind of cool. Yes? Okay, all right. So, I mean, that's the kind of stuff you could play around with. But I want you to realize something even more important about what we just did. As you're doing your polar homework, which really should be done, but if you're still doing it, Desmos can help you, right? You can just come and pop in Desmos, kind of check your work, see if it's coming out right. Just you have to use R and just, how do you make theta in Desmos?
Type theta.
Yeah, just start typing the word theta, T-H-E-T-A, and it'll replace it with theta. I like it. So Desmos can totally do polar, and it can do parametric. Did I show you parametric on the Desmos? I don't know if I did. I'm doing like parametric and polar stuff with my calc class, so I can't remember if I showed you. Let's do it down here. To do a parametric one, I can type in like a point. I just have to make it a point. So this is the x piece of the point, right? T squared minus 1, and this is the y piece of the point, t plus 2. And there you go. This is x equals, this is y equals. And then I can control what to put in for t. Right? You guys kind of with me? And of course, if I throw in there like sine, things should get more interesting. There, look at that funky thing. That's already funky. Let's put a 3 there. There we go. Now we're starting to talk about something. Anyway. So Desmos is really nice. If we had enough computer labs, we'd probably teach pre-calc in a computer lab, so then we have access to, everybody have access to graphing stuff like this. We don't, so we don't. Okay, maybe. And of course, just to remind you guys, you don't have Desmos with you all the time, but you do have your graphing calculator, or at least the one you borrow. And right now I have it in polar, but you can very easily switch that to, very easily, there it is, Jeff. Switch that to parametric, and then it can do some nifty stuff. There's that diagonal ellipse, right? I think we did that a while back. If I change this, let's see what happens if I change this to 3. Okay. Sorry. Just to play with it, just to see what happens. So now it's kind of like out of phase. It doesn't make a nice ellipse because the angles don't agree. When you make the angles not agree, that's where you get the really kind of cool shapes. Yeah. Enough of that. I just want to give you enough stuff to try to play with some stuff. So let's go to this question somebody had. The question is about number 40, right? So I'm a teacher. I'm evil. I'm going to do number 41. So you guys can read that. That number 40, I think, is part of the homework. So this sounds difficult. What they want me to do. So real quick, I want to do a couple examples before we do this. If I was given this, y squared equals x minus 2x cubed. Let's do this. There. Okay. How do I parameterize this? What's one way I can parameterize this? So what does it mean to parameterize something? I want to make x a function of t, and then y a function of t. But they have to together make this. The easiest way to parameterize something that is already solved for a letter is to just make the other letter t. So if I let x equals t, if x is t, what's y then? If x is t, what's y? T squared minus 2 t cubed. That is admittedly the most boring way to parameterize that curve. Right? A slightly more interesting way, let me do a second thing. What if I let x equal cosine t? What's y? Cosine squared t? Minus twice cosine cubed t. I love it. Okay. Now one little thing, let's see if you guys get this. In this original equation, can somebody give me some idea what this looks like? You were in pre-calculus. You have to be able to look at this and just kind of give me an idea what it looks like. What's the end behavior? Say again? Yeah. Okay, so it's going to do the opposite of what a cube normally does because the cube is negative, right? So it's going to do this kind of thing. I think I'm looking at you correct, right? Yes. So the end behavior is going to be like this. So it's going to look something like, Jeff, you can do it. Blah. Something like that, right? Yeah. Okay. So how big can x get? How big can the x's get? In this original curve, how big can the x's get? Huh? Infinite. Correct? Is there any highest number you can plug in here? No, I can plug whatever number I want to in there. So how big negative can they get? Negative infinite. Right? If I define, now really try to stay with stress here. If I define x to be cosine t, how big can x get? Yes. What's the biggest output for cosine? 1. How small can x get? Negative 1, right? So real quick, just stay with me. I haven't answered this question at all yet. I know, I got sidetracked, but I got to show you this. Okay. Your choice of how to convert rectangular equations to parametric ones can make it so you can't get the entire picture. So let's see if we can do this. So let me do this first. Let me go to rectangular, it's a function. Put in x, no, Jeff, good Lord, x squared, what was it, minus 2x cubed? I believe. Yes. So of course, if we graph that, kabam, just like we said, right? Okay. Not quite so bumpy in the middle, but still, it's a little bit bumpy in the middle. Now watch this. All right. So everybody's got that picture, right? If I go to parametric and I put in there cosine t and, yeah, what was it? Cosine squared t. Oh, come on, you crazy. Why did you do a, okay, there we go. Got it. Let's see. Bam, cosine t, bam, bam, squared, minus 2 cosine t cubed. Okay, let's see what we get. Let me make sure my t window, let's make t go from, sure, -8 to 8, why not? So let's see what I get if I graph this. I did not get the entire picture, did I? Of course I didn't. In fact, where does it look like it stops? It stops right when x is -1. And where does it stop this way? Right when x is 1. Of course it does. So watch this. What if I let, okay, stay with me now, guys. Oh shit, that happened. What if I let x be 2 cosine t? So then there's going to be a 2 cosine t and a 2 cosine t. Now, what's the biggest x could be? 2. So let's see what happens. Now I get more of the graph, and it's going to stop at x equals 2. So let me see if I zoom out a little bit. Oh, I got to zoom out more than that. Dang it. If I go down, yeah, like y min -20. And y max 20. Yeah, okay, y max I didn't quite, but it stops at 2, of course. Okay, maybe. So if I give you an xy equation, how many ways is there to parameterize that? Infinite ways. I could make, if I make x equal the square root of t, then what's y? The square root of t squared minus 2 square root of t cubed. If I do that, can somebody tell me, if x equals the square root of t, what's the smallest x can be? 0. The smallest output for square root is 0, correct? So then I am not going to get this whole piece. If I do that, I'm not going to get anything back here. I'm still going to get points that are on the curve. I just can't get anything below 0 for x because I defined it to be the square root of t. Maybe. All right. I'll stop. I just want to show you a little more what parameterization does. Now, the actual question. I'm sorry. Mohammed's been so patient. He's like, someday this guy's got to get to my question. Let me remind you. Oh, it was number 40. Parameterize the line from blah, blah, blah. So the line is there at t equals 0 and there at t equals 1. That sounds like a lot more difficult, right? Well, let's look at 41. Okay. So, could you guys, in fact, we're not going to do this. Let me see. What should I do here? I can do it a couple different ways. Can you guys just tell me what the equation of the line is that goes through these 2 points? Now that's a question. If you see it on the final, you should go, oh, holy shit, yes. Right? Can you just find the equation of the line that goes through those 2 points? That's all I need for the moment.
Is that a negative?
Say again?
Is that a negative?
-2, yeah, right. 4, 1, 6, -2.
Is that y2 minus y1?
Sure. What do you need to get the equation of a line? You need the slope, right? And you need a point, right? And let me get you to the point where you don't need the freaking y minus y1 business. So the slope is easy, yes? What's the slope gonna be?
-3/2x.
Yeah, -3/2. Right? -2 minus 1 over 6 minus 4. So -3/2. Don't put an x in there yet, just m is a number, right? And let me see if I can get you guys, pick a point, pick either point. Which one? 4, 1, okay. Now you could do this, remember this? Where you plug 4 there because it's the x piece, 1 there because it's the y piece, -3/2, right? Or you could do this and just plug in what you know. I know that y is 1, I know that m is -3/2, and I know that x is 4, so then I can just solve for b. So we got 1 equals -6 plus b, so I get b is 7, is that cool? Okay, so I want us to kind of keep this in our back pocket. So I get that. And to check it, you could throw those points in and see if you put a 4 in there, make sure you get 1 out and so forth. Okay. Is everybody with me? I mean, that problem has to be easy as hell. Yes, okay. Then, right here, I could just say x is t, so y is -3/2 t plus 7, but that's not necessarily going to do what I need it to do. Okay. So, that's all side work. This is not what the problem asked me to do. I just want to parameterize this thing, so forth. So we know what the line equation is. So, watch this. Okay, here's how to actually do this problem. All right, what do I know? At t equals 0, what's supposed to be true? It's supposed to be at 4, 1. So x is supposed to be 4, y is supposed to be 1, right? At t equal 1, what's supposed to be true? X equals 6, y equals -2. So from this, don't I get, so what is x doing? X, so I want to find x is a function of t. That's what I want to find, right? That's what a parameterization is x is a function of t. What points does x go through? Well, when the input is 0, the output is 4. When the input is 1, the output is 6. Let me stop for a minute. Isn't that what x does? When t is 0, when the input is 0, what is x? 4. When the input is 1, what is x? 6. So can you find, what's the slope here? Easy slope. 2, right? 6 minus 4 over 1 minus 0. That slope is 2. So I have x equals slope times t. Can anyone tell me what b is? What's the intercept here? Anyone tell me what b is? What's the y-intercept? In this case, it'll be the x-intercept. But which one of these is the y-intercept? Well, we consider the y-intercept here. It's going to be an x-intercept. Which one of these is the intercept? 4, right? So, tell me, when t is 0, what's x in this equation? When t is 0, x is 4, like it's supposed to be. When t is 1, x is 6. All right, so what's supposed to happen for y? When t is 0, what's y? 1. So I already know b is 1. See it? When t is 1, what's y supposed to be? -2. So now I just need to know the slope. What's the slope going to be? -2 minus 1 is -3, divided by 1 minus 0. So the slope is -3. Okay, let me stop for a minute. So I want you to realize, isn't this equation of a line with a slope of 1 and an intercept of 0, isn't that x equals, but this is like t is an input, x is the output. Isn't this, t is the input, y is the output, the slope is -3/2, and the y-intercept is 7? Okay, maybe. So here, what do I get? I get y equals, the slope is -3, the input is t, and what do I put here, of course? We already figured it out. Plus 1. So, all right, stay with me now, stay with me. This is exactly how you're going to do number 40. So this is kind of cool. So again, you collect your information. At t equals 0, what do these do? At t equals 1, what do these do? Well, that means I have 2 points for x, and I have 2 points for y. If I have 2 points, I can find a slope. I can find an intercept. So watch this, let me see. If I start with this and this, can somebody remind me, how could I eliminate the t? How could I kill the t? What can I do? How do I do it? Eliminate the parameter. How do I do that? Yeah, if I take one of these, like take the first one. How do I solve it for t? Subtract 4. Divide by 2. So then I can plug that into the second one. So I get y equals -3 times x minus 4 over 2 plus 1. Yes? Okay, isn't this -3? How do I want to do this so it's easier? -3, let's do this. X over 2 minus 2, is that cool? So then I can distribute the -3. -3 times -2 is plus 6. And then I get -3/2 x plus 7, which is what it's supposed to be. Crazy shit. So again, let me see. If somebody gives me an XY relationship, right? The easiest way to parametricize this is to I always mispronounce it, is to make x equal t, then y equals 4t minus 1. Easiest way to do it. But what's another way to do it? I can let x equal to 3t plus 5. If I do, I can make x equal whatever shit I want to. And then what does that mean y has to be? If x is 3t plus 5, what must y be? If x is 3t plus 5, y has to be 4 times, and what's x? 3t plus 5. So y would have to be 12t plus 20 minus 1. So there's an infinite way to parameterize something that somebody gives me. My choice of how to do that affects where things are at certain times. So when t is 0, what's x? Up here in the first one. When t is 0, what's x? 0. When t is 0 here, what's x? 5. So again, in real life, what could parametric equations represent? Motion of, let's say, a missile or something, or a comet coming towards Earth. Wouldn't I want to know not just what point it goes through, but when it goes through that point? At what time? Yes? Wouldn't that be good? So we're like, here's the point that represents Earth. I would like to know when this is going to be here. Because that means, oh shit, right? Do you guys understand? If I don't know when that happens, I don't know how much time we have to send some old people up there to try to blow it up or whatever, right? I don't know. You guys with me? So that's one reason why we call this T because very often it does represent time. So if I think my comet at t equals 0, if I think it's at x equals 0, I could be wrong. Maybe at t equals 0, it's supposed to be at x equals 5. So I need to set up my equations to actually capture that information. Okay, I know. Mohammed, I went a little further than the question, but does that help? Okay. Again, I did a lot of stuff before, I did a lot of stuff after, but you just have to do what I had up here a second ago. You just have to get to these equations, right? Okay. Okay. Anything else from homework or anything else before we get back into this worksheet? Okay, just to let you know, this problem is one of the harder problems to kind of get, right? Which is why if nobody asks the question, I always get worried, so I'm kind of happy somebody asked the question. And again, as always, I kind of went a little off on tangents with this problem. Okay. So, I think everyone at this point, well, let me know, does anyone not have this worksheet here? Say again? If not, I'm not sure what to do for you because I think I just gave out my last one a minute ago. Which seems impossible because I printed out more than there are people. But that's okay. We did the second one last time. Sorry?
Together, right?
Yes, I think we did that one together. I think I'll let you guys do a little bit. What shape would number 1 be? Yeah, why could 1 not be a hyperbola? Let's start there. Why would 1 definitely not be a hyperbola? It's a plus, not a minus. Immediately I can rule out hyperbola. How do I know it's an ellipse, not a circle? Coefficients are not the same. It acts differently in the y direction than it does in the x direction, correct? Okay, what about number 3? Circle. Yeah. And I know, if you guys are paying attention, the things I ask kind of give it away. But on a test, I'm not going to give it away by what I ask. I'm just going to say, find the important parts of this thing, blah, blah, blah. You guys kind of with me? So you can tell it's a circle because it asks for a center and a radius, but still, you should be able to tell from the equation what it is. So let's look at this first guy. Does anyone know how to, well, we know it's an ellipse. What's the length going to be on the x-axis? How far is it going to get away from the center? Yeah, so whatever number is with the x, you square root it. So it's going to go out 3 in both directions, right? What about on the y-axis? 5. So it's going to go up and down 5 on the y-axis. And thankfully, where's the center of this ellipse? Yeah, it's not been shifted at all. And again, if you wanted to do the foci, it would be c squared equals 25 minus 9. C squared equals b squared minus a squared. Right, so c would be 4, but I'm not going to focus, again, here's my pathetic joke that it didn't even mean. I'm not going to focus on the foci. Don't worry too much about the foci at the moment. So it's what is it about the form it's given to me that I know I can just pick these things out? So for example, if I had a line, that, give me paper. There, paper. Got a line that looked like this. Are any of those numbers the slope? Are any of those numbers that I see the slope? What's the form of a line? Is it in that form? Is that in this form? Hell no. So can I tell anything about this at the moment? Nope. What would I have to do, of course, to be able to tell something about it? I have to put it in this form to get y by itself. Are you guys with me? We know this. We know this. The neat thing about that idea, that if I put something in the right form, things just pop out at me. It holds for so many things. So what does an ellipse look like in general? It looks like x squared over a squared plus y squared over b squared equals 1. That is the form. If it equaled 4, it's not in the right form, right? So what if I had this? What if I had x squared over 9 plus y squared equals 4? Shit! 3 doesn't mean a damn thing, right? How far does it go on the x? Don't say 3, because it's not in the right form, right? Just like mx plus b. So what do I have to do to get it in the right form? I have to divide by 4. I need a 1 there, right? So if I divide by 4, I really want you to get this. I just put a 4 down there. Just divide by 4. There's already a 9. So now I get x squared over 36 plus y squared over 4 equals 1. Now I know it's going to go 6 left and right. And it's going to go 2 up and down. Are you guys understanding? So a lot of things in mathematics, when I want to see an equation and I want to think about it graphically, it's got to be in a certain form. And the same thing for an for a hyperbola. It would just have a minus there, right? Okay, maybe. So now this thing is not shifted. I know exactly how far to go. It's desperately got to be easy. Start at the center. How far up do I go? How far up do I go? 5. And I go down 5. How far left and right do I go? 3. Basically done. Then you, oh my gosh. Okay. Let's make a stupid joke. Kind of reminds me of the big heads. Show me what you got. Okay. So how did I know this is going to be like standing up, like long this way instead of long that way? Because the number with the y was bigger. That's why. That's why it makes sense. If these numbers are the same, it goes the same distance out, so that makes a circle then. All right, so what about number 3? What's the main thing to be careful about on number 3? Obviously is a, did we say this yet? What is number 3? Circle. How do I know it's a circle? Coefficients are the same. They're both 1. Do you see that? On the y squared piece and the x squared piece, they both have the same coefficient. So it's going to act the same way. But what's been changed? What's different about this circle than normal? Yeah, where's the center now? Yeah, so remember, when it's in with the variable, it goes the opposite of what it looks like. So it's going to go back 2, and it's going to go up 1. And what's the radius going to be? Yeah, because it's, in general, it's equal to x squared plus y squared equals r squared. So the radius is 3. Which means, if I find the center, I just go 3 out in every direction, and I'm basically done. So negative 2, 1, just negative 2, 1. There's the center. You put like a little C there. Just don't put a point there, because the center is not a point on the circle. And then I just go 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And then I try desperately to make something that looks vaguely circle-ish. All right, for me, that's not bad. So that's the beautiful thing about a circle, just go the same length out in all directions. That's one big reason why this doesn't have to be a 1 for a circle. I could make it, if I divide by 9, do you see how it does say go out 3 in the x direction, go out 3 in the y direction? So that's, I'm sorry, you would see it better if I put it. Do you see if I do divide by 9 and make this a 1? It still says go out 3 in the x direction, go out 3 in the y direction. Same thing with ellipses, except now I'm just going at the same, so of course it makes a nice circle. Okay. Maybe. All right, so let's try one. I wish I would have brought, that's too bad, Joe. I'll make one on the fly. Or maybe I can do this. Let me see. Is it here? Yes. Okay, beautiful. Okay. Ooh, that's pretty gross. Let's do it. So what if I have this? 4x squared minus, I'm sorry, start over again. 4y squared plus 16y equals 9x squared minus 18x plus 29. Chumba Wumba. How do I know this is not a parabola, for example? How do I know it's not a parabola? It's definitely not a straight line, right? How do I know those things? Which variables are squared? Both. If only the x was squared, that would be a parabola, right? I can make it y equals blah, 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 x squared stuff, right? Only the y was squared to be a parabola just opening sideways. So what the shit do I do? What do I do with this thing? I don't know. Don't you wish it looked like, if it looked like this, for example. Minus y minus 7 squared over 16. If it looked like that, then I know everything, don't I? I know the center, I know how far it goes in the x, how far it goes in the y, blah, 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 right? Okay, maybe. So what do I do to make these kind of things show up? I need to gather all my x and y shit together. Well, one thing I was nice about on this one is, don't I already have that stuff together? Okay, let's see. So it's all about completing the square. Do you guys remember how to do that? What do I have to do if I want to complete the square for the y? Do I have all my y's together? Yes. So what do I have to do to complete the square? What do I have to do first? No. The very first thing I need, the first number is supposed to be a 1. So I have to factor a 4 out. So I'm leaving some room at the end. Now I do what you said, Christian. Half of 4 is 2 squared. I'm going to add 4. Right, what did I actually just add? I added 16. Now you could either say minus 16 here, or you could just add 16 to the other side. Right? If I add 16 to this side, shouldn't I add 16 to that side? But we can do this. Let's go ahead and do this, because I think you guys are a little more used to, I added 16, so I better subtract 16. It doesn't matter which way you do it. So what do I have to do over here first? My x squared, does it have the right number in front of it? No. What's supposed to be there? 1. A 1. So what do I take out? 9. Leave some room. Right, so completed the square was built on the first number being a 1. Once I get that, how do I do this? I take half of this squared. What did I actually just add? 9. So I better subtract 9 at the same time. So why do we do all that crazy shit? That looks worse, Jeff. That looks bigger and worse, and thank you, and what the shit? Well, how does this factor? Remember the middle step was half of 4 is 2? That's exactly how this factors. How does this factor? Half of negative 2 is negative 1, so it factors like x minus 1. And 29 minus 9 is 20. Now remember our goal, right? What's our goal? Our goal is to get something that looks like this. That would be awesome. So what's in the wrong place? So many things. What's in the wrong place? I want it to look like this. So I want my x's and y's to all be together, correct? So what do I need to do? What's in the, yeah, I need to get this over there, so I've got to subtract this. Whew. And then I can add 16. All right, that's looking a lot better. And of course, what's the only last thing that's not what it's supposed to be? 36. It's supposed to be 1, so I just divide by 36. Four over 36 is 1 over 9. 9 over 36 is 1 over 4. Okay, so when you have, how do you know when to complete the square? When you have y squared and y. You got to get those together. Or x squared and x's. You got to get those together, right? I got to collect all that shit together. That's what completing square does for me. It takes all my y shit and bam, puts it all together in a nice little compact form. It is definitely not obvious that this is the same thing as this. Yes? Of course. No, we did a lot of work to it. So we took this thing. It looked ugly at first, but now it looks really pretty. So tell me, what shape is this going to be when I graph it? Sorry? Why will it not be a circle or an ellipse? There's a minus. The whole thing about when there's a plus, it's a closed thing. When you add two positive numbers, one can't get totally big. They have to kind of offset each other. When it's minus, that's when they can go crazy, right? So that's a hyperbola. Okay. And of course, hyperbolas are always a bit more interesting than anything else. So this is a hyperbola. What's the center? Yeah, the center is going to be, you got to be a little careful. I think you said it right. What's the x going to be? 1. And the y is going to be negative 2. Yeah. So that's the center. How far am I going to go out in the y direction? I'm going to go 3 out in the y direction. Right? Because that's 9. How about the x direction? 2. Okay. And is it going to sit on the x-axis? Is it going to look like this, or is it going to look like this? Which term is positive? The y term. So it's going to sit on the y-axis. let's see how to graph this. I don't know what you're doing, Jeff, with all the paper. Oh well, so much paper. All right, let's see, what's the best way to do this? I'm gonna zoom out a little bit. Okay, that'll work. So let me put the center. The center is at 1, -2. Give myself a few things. Bam, 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 bam. Bam, 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 bam. 1, -2. No, don't put a point there, Jeff. Put like a C for center. Okay. And we said we're going to go up and down 3, right? So 1, 2, 3. 1, 2, 3. 1. And then in the X direction, we're going to go 2. 1, 2. Why did I put open circles that way? Because what did we say it's going to shape like? It's going to be shaped like this. Right? Okay, maybe. Do you guys remember what to do next? I'm going to draw what now? Rectangle. All right, cool. And then I do my asymptotes out through the corners. And then since it's going this way, I'm going to take this and I have to follow my asymptotes. Wee. Is
it up and down because the y is in front?
Because the y is positive, exactly. Right? If this would have been, this was here, if these were switched, it would have looked like this. I would have done this.
Is there ever a chance where they're both negative?
So, if they're both negative, all right, now watch this. So let me do this. So if I had negative x squared, just to make it easy, I'm going to make it not shifted. Cool? Negative x squared over 9 minus y squared over 4 equals 1. Let me multiply both sides by -1. Right? So then all these negatives cancel. So we had x squared over 9 plus y squared over 4 equals -1. Can that happen? Is this positive or negative or both, or? It's always positive or 0, and this is always positive. So positive plus positive equals -1. Is that possible? Can I add 2 positive numbers and get -1?
Add 2 positive numbers?
Can I add 2 positive numbers and get -1?
No.
Nope. So that would lead to no graph, or at least no real graph. If I extended my dimensions to include complex numbers, I could graph that thing, but let's not do that. Okay. You have to get out the 64 pack of crayons. I don't know if you remember when they lifted it, it was all colorful. Let's not do that. Okay. That's a good question, I like that. But that would lead to crazy sauce, yeah, okay. So again, 2 levels to these problems. What kind of shape is it? So you have to tell. If it's a plus, it's a circle or an ellipse. If it's a minus, hyperbola, right? Hyperbola is the hardest one to graph, but it still, was this really difficult? Find the center, and then you know exactly how far to go up and over and make a little rectangle, go through the corners. It's actually surprisingly simple. Maybe. Okay, maybe. Okay, guys. Well, tomorrow, totally devoted to review. I might even have a video left over from when I taught this over Zoom. But I'll also bring a final exam solution sheet, right, the answers. But I think there's a video from a few semesters ago. I'll see. Either way, I'll have answers tomorrow for the practice final.